So in this lesson, we're going to take a look at how to solve a system by using elimination, or sometimes it's known as linear combination. And it is my favorite way. I just like it because it ends up getting rid of things and just makes things more simple. So we want to stack like terms. So x's, y's, and then our constants there, creating a pair of opposites by multiplying one or both equations. So we want the same number, but them to be opposite. So I would see that this is -5, and I could easily make this +5 by multiplying by -5. So I'm going to go ahead and distribute that, in a sense, to every single term. So -25x +5y equals 19. And I like to rewrite my top equation so that they're right above and below each other. And that one's not changing. So now I can go ahead and eliminate my y's. So I'm going to add my x's. And then I'm going to divide. And, oops, I forgot to multiply that 19. See my mistake there? I forgot to take that 19 times the -5. So that should actually be -95. So we got to double check and make sure if things aren't quite pretty, we got to go back and see where we made our mistake. So that should be -88. And there we go. Now we can see that x is 4. Now, not everything is pretty, but it kind of indicates maybe you made an error somewhere if it isn't. So good to double check. So we've got the first part, and now we need to substitute and solve for the other variable. So we've got a 5x minus y equals 19. So I'm using that bottom equation there, and I'm just going to plug my 4 in for x. So 20 minus y equals 19. Subtract 20. -y is equal to -1, which we don't want -y, we want +y. So we end up with y is 1. So my solution is going to be 4, 1. So very similar again to what we have seen for our possible solutions for the other systems, graphing and substitution. So this is our last one, the third way, by elimination. So can you see a pair that we could get? Well, 3 and 6, those kind of have common multiples. If we multiply this by 2, because it's already positive and negative, so I'm going to do -8x, take that times 2, -6y, don't forget the 18, and that is 36. So now I'm just going to kind of cross that out. And then I'm going to cancel my y's, add my x's, so -3x equals 27, and then divide everything by -3. So x equals -9. So we've got the first part. Now we need to plug it back in to one of those equations. So we'll just go ahead and plug it in to that one. So 5 times -9 plus 6y equals -9. And then we multiply here and add the 45. 6y is equal to 36. And divide by 6. So we get y is 6, which means my answer is -9, 6. All right. Next one. Oh, this one, I could just multiply this by -2, and that would give me +10. So 10x +4y, 0 times anything is 0, and I'm going to go ahead and write that top one down here, not changing it at all. So that cancels, that cancels. Oh my, we have 0 equals 0. So that is true. So we have infinite solutions. All right, multiplying on this one. Let's go ahead and take this times 2. That will give me positive 14, negative 16y, and 4. So I'm going to get that to cancel, that's 0 on this side. And then when I add these, that's negative 12. Well, that's not true. That's false. And when it's false, it's no solution.